Hello everyone, welcome to 3ddesignacademy.com. In this lesson, we'll learn about lead-in. So what is a lead-in? Now, by dictionary definition, a lead-in is something that leads into something else. Now, that sounds simple enough, but what does that mean in terms of surfacing and alias? Well, basically, it means that you are creating or giving a curve or a surface a little bit lead in order to make the transition or a fillet a little bit smoother. Now, that also means instead of G2, you're trying to achieve G3. And let me show you guys how it's done. So right now I have a set of curves like this, and I'm just going to use a curve fillet in order to create a fillet like this. Right now, if you look at the options over here, it's chord G2, its chord length is 600 because the curves are fairly big, and the form factor is set to 1. Now, I've probably dealt with this in some of the previous videos, especially in continuity. But if you look at the curvature comb here, you'll see that while it looks smooth, the curvature comb itself has a little bit of break over here. Well, I wouldn't say it's a break, but it's a little bit abrupt over here. Now, if I were to just turn the curvature comb off and you just turn the controls off, it looks pretty darn smooth, but we can make it even smoother. So if I were to just copy and paste these curves over here like this, and I'm just going to connect it with a blend curve like that. And let's turn the curvature comb on like this, and I'm just going to turn it on for this side too. And what I'm going to do is I'm going to give it a little bit of lead-in on the primary curve. And let's see what happens to the comb. So I'm just going to pull this, do a little bit of slide, mouse sensitivity of 10 so that it's a little bit slow. I'm just going to pull the CV towards this side. And you'll see that the curvature comb is starting to become smoother like this. And I'm going to do the same thing over here like this. You'll see that it's actually transitioning very nicely over here. Now, there are two ways to do this. You can either change the primary curve, or you can also give it a G3 continuity over here. And let me show you guys how that's done too. So actually, for this one, let's do this. I'm going to, instead of G2, you can do it several ways. One of the things you can do is give it a form factor of 0.5, which will give it a nice transition over here. But if you want to go really smooth, what you can do is you can go G3 like this, and you'll see that the transition is very smooth. Now, a little different shape between the two because the methods are different, but you are essentially giving both surfaces or set of curves a lead-in to make the transition a little bit smoother. Okay, so now we've done that in 2D, and let's go over to 3D. So I'm just going to hide these curves over here, and you'll see a prime example of lead-in on the roofs of cars. Actually, let me show you a picture. I believe this is a BMW X7. Now, it's kind of subtle, so it's kind of hard to tell, but you'll notice that there is a little bit more acceleration towards either end. Now, another example that more, I guess, apparent example is probably a roof line as you view it from the side. As you can see over here, we have a primary surface here, but the transition over here is actually very smooth. And more than likely, this is probably a G3 continuity because of how smooth the transition is. And let me show you an Alias example. So what I'm going to do is right now, actually, let's do this. I'm just going to, right now, if you look at the CV structure over here, it's pretty constant. And if I were to do a curvature comb here, well, let's do this. I'm going to do a curvature comb here, like this. Over here like that. Now, it's actually pretty smooth because this fillet over here is actually, well, it's got a lot of lead-in in the fillet itself. But what I'm going to do is I'm going to make it a little bit better by giving acceleration towards the primary surface. Because if you were to just look at this, yes, there's a little bit of acceleration towards the end, but I don't think it's quite enough. So here's what I'm going to do. I'm just going to project a line. Project the COS over here. I'm just going to trim this one and trim this one over here. And let's turn the curvature combs on. Oops. Let's turn the curvature combs on like this. Okay, I'm just going to make it a little bit smaller. And what I'm going to do is I'm going to give it a little bit of acceleration towards the front side. So I'm just going to drag this over here and I'm just going to slide it over here like this. And you'll notice that there's a little more acceleration starting to happen like that. And I'm going to do the same thing over here. And let's give it a little bit of acceleration towards this side as well. So now it's a little bit on trend, but that's okay. I'm going to be fixing anyways. But you'll see that the curvature comb is rising as it goes towards the center. That means that the curvature, there's a little bit more acceleration towards this end. And that's going to make the transition a little bit smoother. Okay, so now that's done. Let's go ahead and do this. So I'm just going to delete the COS because I don't think the location is good. And I'm going to just do an insert over here. So I'm going to take this one. I'm going to snap it over here. And I'm going to take this one over here and I'm going to snap it like this. And I'm going to trim both sides. Now, the curvature, the surface itself right over here has a lot of acceleration on it too. So this is probably going to be very similar, but it's going to have quite a big difference if you were to just do a regular standard G2 instead of a G3 like continuity. So I'm just going to align this one over here like this. And I think, oh, actually, let's turn auto scale G2 off. And I'm going to just align it over here. Position influence is set to max so that it's nice and tight. And let's check the continuity curvature comb over here. So I'm just going to transition over here. Now, I don't know why this one has a little break, but as you can see over here, the transition is even smoother than before. Now, compare this with if I were to just, oops, I don't want to move it that way. If I were to just do a freeform blend here, like this. Well, I do want it to be G2, so let's go ahead and do that. So let's make it a G2 over here. And I'm just going to align this one over here. Because right now, I think it's got a lot of spans. So let's make it a 5 degree. I'm going to reduce the spans to 1. And do the same thing on the other side. So right now the CV structure is a little bit ugly, so I'm just going to rebuild that. So I'm going to say 1 is curvature, 3 is curvature. I'm just going to check the shape. So it's going to be 1, 2, 3, and 4. And let's get rid of the original. And I'm going to do the same thing. I'm just going to turn the patch precision on like this. And let's just check the curvature. Now, you see that there's a little bit of acceleration on the primary surface, but the transition here is a little bit more abrupt, whereas this one is very nice and smooth. And if you were to check the highlight over here, well, I mean, it's very subtle, but you'll see that the transition over here, right here, the highlight you see, you read right over here, the transition is a lot smoother than this one. I think this one, I feel like there's a little bit of abruptness to it. So that's what a lead-in does. And it does make the transition a lot better, especially for surfaces that are large. Now, this one is kind of hard to identify, but one of the other ways that you might need a lead-in is a surface situation like this. Now, these surfaces seem pretty similar, but if you look at the structure, they are a little bit different. So this one over here, if you look at the structure, you'll see that the curvature comb, if I were to put a curvature comb here, it's pretty flat. It's pretty even. If I were to do this, well, basically, what's actually kind of hard to see because it is so flat. Let's see if I can do it on here. Well, maybe. It's kind of hard to see, but well, the CV structure is pretty flat, but if you were to just look at the CV structure over here, you'll see that I put a little bit of acceleration towards here, and I also made this a G3. Well, basically, well, not exactly a G3, but I gave it a little bit more acceleration. Now this one, I think this is a similar example. Actually, you know what? This one I don't think I need, so let's get rid of that. All right. So this one, I gave it a little bit of acceleration on the primary surface, and I also gave it a little bit of acceleration on the fillet itself. So the transition is going to be really smooth. It's almost going to be like G3. If I do curvature comb, unfortunately, it won't let me do that. So actually, you know what? Let's see if I can just duplicate the curve, see if it shows up better. I know it's a flat over here, but I'm hoping at least I can see this one over here. So you'll see the CV structure difference. And let's put the combs on, see if that... Okay, so maybe that one might be better. Okay, so if you see this one over here, there's a little abruptness here, whereas this one, there's a nice transition. It's almost like G3. Now this one, I think I probably have to scale it down a little bit, and you'll see that the comb has a very nice transition. Now this might not seem like much, and the surfaces seem pretty similar, but if I were to put a fillet here, I think that might explain things a little bit better. So what I'm going to do is I'm just going to put basically a quarter length of 30 fillet over here, edge align on both sides, and do the same thing over here, like this. And I'm going to be, well, let's take a look at the surface. If you take a look at the surface, I feel like there is, well, I don't think it's really, this is probably more of a illusion than anything else. But I also, I feel like there is a little bit of directional change. So I feel as though this is going straight, it's going up like this and going back down and going up. So basically the transition seems a little funky, especially around this area. Now let's do the same thing where the surface has a little more lead-in, and let's see how that looks. So I'm just going to put the same fillet. It's going to be quarter fillet of 30, and I'm just going to do edge line over here. And if you see this one over here, I don't see that transition there. I don't see that weird kink that feels like it's going up and down. This one, it just looks like it's transitioning nicely to the other primary surface. So this is another way lead-in is very critical for building good surfaces. All right, so that's what a lead-in is. Thank you guys for watching, and see you next time.